Right, this lesson is on special products. The first one is going to be on squaring the binomial. So when we have a plus b quantity squared, that is simply a plus b times a plus b. Now there's a pattern here. So when we distribute that out, FOIL it out, we're going to end up with a times a is a squared, a times b is ab, and then b times a is ba, but then we can use Distributive property and switch that to get ab. And then b times b is b squared. You add 1ab plus 1ab, you get 2ab. So here is our pattern, a squared plus 2ab plus b squared. And similarly, for when we have a minus b quantity squared, we get a squared minus 2ab plus b squared. So the only difference here is this sign right here when we're doing that. So there are two ways we can do this. So I'll show you the pattern way, and then I'll show you another way. So the pattern way says we have x plus 5 quantity squared. So we are squaring a binomial. We have two terms, squaring it. So it says we square the first term. So that's going to be x squared. The product of a and b doubled. So x times 5 is 5x. Doubled is 10x. And then square the last term. Now, the other way to do this, and I'll be honest, it's actually the way I recommend, is what does it mean to square something? So if I'm doing x plus 5 quantity squared, that means x plus 5 times x plus 5. And then I can just use my FOIL technique that I learned in the last lesson. X times x is x squared plus 5x plus another 5x plus 25. I have these middle terms I can combine, and I'll get x squared plus 25x, plus 10x. I was looking ahead, plus 25. And notice we get the same thing we did when we use our pattern. This is a highly missed problem. It potentially is the most missed math problem ever, in general in algebra class. It's very tempting to say this is equal to x squared plus 25. Because recall when we looked at products, we could apply that exponent to both terms. We can't do that with binomial terms. So let's expand this one. Y minus 3 quantity squared. Now, I'm going to recommend that we just go ahead and do y minus 3 times y minus 3. And then FOIL it out. Y times y is y squared. Y times minus 3 is a minus 3y. And then negative 3 times y is another negative 3y. Negative 3 times negative 3 is a positive 9. Now I can combine these two middle terms. So y squared minus 3 plus 3, again, plus a negative, is a minus 6y plus 9. Now notice we could have used the pattern on this. So what's the pattern say to do? Square the first term. So y squared, there we go. The product of these two terms doubled. So the product of negative 3 and y is negative 3y, doubled, negative 6y. And then square the last term. Square negative 3, you get 9. Okay, next one. So 2a plus 7 quantity squared. So pause the video here if you haven't done so yet and try to do this one on your own. All right, welcome back. So 2a plus 7 quantity squared. I'm going to recommend that you do 2a plus 7 times 2a plus 7. Now, once you get pretty comfortable doing this, you'll actually seek out those patterns. Mathematicians love being lazy, they say. And I say, we try to find patterns to make it where we don't have to write everything out every time. So, but I would get good at this first. So 2a times 2a is 4a squared. 2a times 7. Again, I'm just multiplying this out like I did before. 2a times 7 plus 14a plus another 14a plus 49. These middle two terms I can combine. So I'll get 4a squared plus 28a plus 49. Students that often try to use the pattern, this is one of the ones where they'll miss it. Square the first term, it's 2a quantity squared. So we have to have parentheses around that, and which gives us 4a squared. And then product of 7 and 2a is 14a, doubled is 28a, and then square the last term. Okay, try this one. 3m minus 4 quantity squared. You know me, I'm going to recommend that we just write down 2 copies of that. A lot easier to teach this way too. You can see kind of my thought process. So 3m times 3m is 9m squared. And then 3m times a minus 4 is a minus 12m. Negative 4 times 3m is another minus 12m. And then negative 4 times a negative 4 is a positive 16. Make sure you see, these are not going to cancel out. They will never cancel out when we're doing squares like this. So we're going to say 9m squared minus 24m plus 16. And this will follow the pattern. Square the first term, 9m squared. The product of negative 4 and 3m is negative 12m, doubled, negative 24m. Square the last term. Last one, x plus y quantity squared. X plus y times x plus y. So x times x is x squared. X times y is xy. Y times x is yx, but then I'll use commutative property to flip it and to say xy. Plus y times y is y squared. So we're going to have x squared plus we have, and it sometimes helps if you put 1xy plus 1xy, 2xy. Plus y squared. Now, a quick digression on why does this not equal to x squared plus y squared? Okay, I mean, for one, we can see that it doesn't, because when I do what squaring tells me to do, just to multiply it twice, I don't get that. Unlike if I had x times y squared. So what does this tell me? So is this equal to x squared times y squared? Well, we can try it out. What's it mean to square something? There's our question for the day right there. xy times xy. So x times x is x squared. Y times y is y squared. So it is equal. That's what allows me to apply it to both the top, to both parts here, to both factors. Whereas I can't do it here is I don't get the right answer. And the similar on, we had x divided by y squared. Can I apply the exponent to the top and the bottom? Well, I can try it out. Squaring something just means multiplying 2 copies of itself. So x times x is x squared. Y times y is y squared. So yes, I can. It works out. So I hope that helps.